computer. Whoa, that's loud. Okay. So good. What is today? Wednesday? Good Wednesday morning. Okay. A few things here before we start here. Let's see. It's recording. I'm going to go here. Let's go to the schedule. Let's talk about this here. So I have 1.8 for today. Then homework 1.7. When is your PSAT?
Saturday.
This Saturday? Okay, so that's why I moved this guy. Is that right? Originally it was this Friday or something, or the Monday after? I think that's why we did it, right? I stretched it out a little bit here. So PSAT, the 16th is when you guys your PSAT? Okay, I wish you well. So after that, we come back, we're gonna do, let's see, we're gonna do a review after that, and then we have a test on the 20th, test 2. So I need to give you guys a study guide here pretty soon for it. Okay, and then before we begin, I have this one here. So anybody heard of a YouTube channel called Number File?
Yes. We tried to watch it.
When? Oh yeah, that's right, yeah. But besides this class, have you guys ever seen it? Elijah, one? Joe, yes, no? Yeah, okay. Okay, it's a channel of people that are interested in just numbers in general. We'll do a few things from here, but let's do with one. This one's kind of cool here. It is dice and how we deal with them.
I've been reading some Martin Gardner books, all sorts of gems in there. Here's one I haven't practiced very much. It just needs a die. I want you to pick a number on the die. Don't tell me what it is. So I can't actually see anything at all.
Yeah.
Which means that you can feel free to sort of, I don't know, show to the video watchers.
Let's go for that number.
A whole number, right? You haven't gone and picked pi or something.
No, it's an integer,
Okay.
and it's on a die.
Good. You should be able to see 3 numbers on the die.
Yes, I can.
Can you see your number?
No.
No, interesting. Can you see your number now?
Yes.
That's interesting. Can you see your number now?
Yes. Is it the one on top?
I think so.
Yep. You got it.
Well, I'm excited.
How did you do that?
Just
Can you take
geeky math
it so
people.
people can do it to their
That's all
parents?
it is.
Do you have any idea? Because I've never tried this trick on anyone before. And first of all, with all magic tricks.
And what's a ladder doing right back of him? That's the
When you
other
know the
question I
trick,
have.
things lame. I think I've just done a lame thing. Is it at all interesting that I could know with blindfolded what your number was?
Yeah.
Okay. Can we try it one more time?
Okay,
Yeah,
try it one more time. Let's go.
Start to spot what's going on. Like all magic tricks, you repeat it. You're like, wait a second. So,
All right.
so you decide a number again.
Let's go for that number.
I'm trying to point a corner towards you. So
Yeah.
it's interesting on a D6, you can only ever see 3 numbers. Can you see your number now?
No.
Interesting. So let's try the question again there. Can you see your number now?
Yes.
That's interesting. What about now?
No.
That's very intriguing. Why would you choose that number?
Yes.
Okay, let's stop there. What's happening? What do you guys say? Magic trick. He's seeing underneath his yeah, okay, cool. Uh-huh. You have this whole concept of notice that he always sees 3 faces, right? And if it's not in that, he shows another 3 faces, completely different, right? And then if it's a no still, let's see, you have to, in fact, if it's a no here and he shows the other 3 faces, this has to be a yes. True? Because there's only 6 faces, he's going to show. So the first 2 sets are going to be either a yes or a no, or a yes, no or a yes. And then from here, he does not know because it's all new faces right here, right? So he has to now quantify. He has to shuffle these around just a little bit here to find out, hey, I'm gonna separate these 2, and I'm gonna see if this one works. So he's gonna shuffle these around, and if it's a yes, that means it's gonna be this one. We good? So it's the little shuffling aspect of things. If it was a yes initially, like, yes, it's initially here. Okay, cool. Then I need to separate these two and these two somehow to figure out what it is. So the question is, how fast can he do it in, or how many questions, or how many, let's see, times does he ask the question? He's always asked 3 times, doesn't he? He says it's always a 3 set. And he goes on to explain why it's so here, because from the 3 faces that you're given, you can go in three questions, you should guess the 6 answers here. Another one similar to this one, you guys talk to me about this one here. Let's see, you have 3 gold bars, or which look like gold bars. One of them is fake. So one of them is it's actually lead in the middle, so it's going to weigh heavier. It's going to be heavier than so it's just coated gold. So question is this: how many times would you have to weigh these in order to find out? Say again? No, can't cut them. You just only weigh them. That's it. So you have 3 gold bars. One of them's fake. You have to pick out the fake one right away. Or how many times do you have to weigh them? I figured, so I'm going to weigh this one and this one, right? I'm going to weigh this one and this one. Right, then I have to weigh this one and this one, right? Perfect. Okay, cool. If you weigh these 2 and they weigh exactly the same, that's the fake one, right? And if you weigh these 2 and this one goes further down, that's the fake one, right? So easy. So you have 3 different combinations or 3 different items here, and you only need to weigh them once. So interesting. 3 items, you only need to weigh once. 6 items, right? Because there's 6 faces to a 6 faces die. And then we need to have 3 sets of questions to get, at least minimally, to get to the correct answer on that. That's pretty interesting. So I wonder where the gap is. So my question is, as a math person, my gap is, okay, how about if there's 4 pieces? And how about if there's 5 pieces? And so is there a minimum? Is like a 5-sided die or a 4-sided die? If it's possible. I think 5-sided die might be possible. So where's the 2 come from? When is the 2 going to be the minimum? So notice for 3 pieces, 1 is the minimum. We're good? We know for 6 pieces, 3 is the minimum. So the question is, what's the minimum for 4 different objects or 5 different objects? Where's the 2 come in? I don't know. Okay, we're good there. One math little thing. Okay, and then some trivia question. This is from a long time ago. This is when Noah asked the question about truth tables. So here it is, guys. Here's things to ponder on a Wednesday. So you have these 2 doors. This person here, he always tells the truth. Always. And then this person here, he always lies. Or one or the other always lies. Oh yeah, that's right. Yeah, you don't even know, but you don't know who is telling the truth, who lies, right? And you're standing here and trying to figure out which door is going to lead to $1 million.
Heaven. I've heard it always says heaven.
Or a crocodile.
I love that. Can I be crocodiles?
So you don't know which one tells the truth. You don't know which one's lying of these people. And then you can only do it. You can only ask 1 question. We're good?
I have a really boring way to answer this.
Yeah.
Just like hold up something colorful and ask them what color it is.
Okay, so hold on. So if you hold it up,
One question.
yeah, you can only ask 1 question. So if he says white, you've asked that question, but you don't know which door to open. Right? You have to answer.
I assume.
Wait, actually, I won't answer because this one's really fun.
So puzzle. Okay, we'll just leave it there here.
When you were
So
saying imagine, then just stop imagining. Problem solved.
Problem solved.
Dollars.
I know, but it's only an imaginary.
Imaginary $1 million.
Then I imagine that I got to the
So there it is. So puzzle is, we're good. Puzzle set. So one of them's telling the truth, one of them lies. You don't know which is who. And you're trying to say which door to open. And for the $1 million, that's imaginary. Okay, we'll go with that. There's our two things for the day. Now let's go to 1.7 homework. 39 is the first one, and then we're gonna try to get to the 1.8 today. 39 is something looks like this. Let's see if that is good. So G is related to one of the parent functions. Describe them. Identify the parent function first. Describe the sequence of transformations, then sketch the graph. Okay, so the parent function F. So that looks like a square root function to me. Are we good there? With this one, that should be this right here. The only thing I'm going to change this up just.
Answer it in the equation form, because when I was answering the other ones, I just said the square root function.
Oh no, it's fine. Yeah, that's easier to write.
What are we trying to do?
For A is identify the parent function that we're dealing with. For B, describe the sequence of transformations from F to G. So what would I have to do? What are the sequence of transformations here? Okay, the only thing is, which we didn't look at last time here, whenever I write this, I like to write it like this, with the X being over here, good, with a little negative.
Well, I mean, it's moved to the right.
I just kind of switched it around. Say again, go ahead.
It's moved to the right 2 spots.
Ooh, this one?
Or is that up?
I think that's up or down. It's down, okay. Down 2 spots, a little +7, what does that do?
Or if it says positive, when you go to the left.
To the left, okay, so we have left, and then the little negative on this side. What's happening here? I'm asking you guys here, what does that negative X stand for?
It's like apart from Y axis.
Awesome, there we go. Okay, one little thing I did not mention to you guys, ready for this here, just to make sure we correct I gotta correct my mistake here. So remember how we multiplied the X's by the negative, right? And that's the Y axis. So real quick here, pay attention because we did not do this last time here. The multiplication has to be on the outside. So here's that. So talk to me about this right here, and we'll finally do the last correction. That should have been a problem I should have done last time. So notice the multiplication is not just to the X, the multiplication is to whatever's multiplying in the X. Okay, we good there? Violet, does that make sense now?
Yeah.
Yeah, okay. So this guy is 2 units down. This guy is 2 units to the right. And we have a Y-axis reflection. Okay, now are we good? Cool. Luke and Joe, does that make sense right there? The multiplication can't just happen to the X only, it's happening to the whole entire process on the inside of the function. There's your Y-axis reflection, but because of that, that 7 is going to have a sign change in front of it. And so we do have to go to the right because of the minus sign. Okay. Do I need to write it out or are we good like that? Okay. And then last one is sketch this graph. And so let's go with, that's going to be B over here then. I'm going to say C is over here. All right, X squared, the square root of X goes like this right here. That's the original function, goes to 1, 1, then 4, 2. So I have myself 7 to the right. That's going to go way that way. We're good. So 0, 0. Let me do this one at least. So it's going to go 7 to the right, 2 down. There's my 0, 0. That's where my 0, 0 went. This one is, I'm going to reflect it about the axis first. So this becomes -1. So then if I go 7 over to the right, I'm at 6, 6, 1. Then I go down 2. So I'm at 6, -1. Are we good there for that one? Sure, we're good. So this one, this was originally 1, 1. I have a reflection about the y-axis, so it gets me -1, 1. I scoot it 7 backwards. That puts me at 6, 1. And I scoot it down, that puts me at 6, -1.
Could you just, if this reflected, could you just count them out knowing that it's 1 up, 1 over, and then 4, 2, can you just do that if you know the spacing?
Say again, Abby.
So like, for example, I know that the spacing for the first one is 1 up, 1 over, and I know that it's reflected, so can I just go 1 up, 1 over, and then to the next one?
Yeah, absolutely. That's cool. Yep. Abby's saying this right here. So notice that this is just 1 up, 1 over. Understanding it's reflected. So that means if I reflect it, it's going to be 1 up, 1 over right over here. So then we go, this way is going to be 4 over 2 up. So from here, 4 over 2 up is going to happen somewhere over here. We're good, which is another way to do it. Yeah, so 2 different ways to do it. You get it off your center point and you do that, or you get it off this. I just want to see where it lands here. Let's see where it lands. So this would be 4, 2. Reflected about the y-axis gets us at -4, 2. Shifted back 7 units gets us to, what do you guys say, 3, 2, is that right? 3, 2, and then we go down. That puts us at 3, 0. Abby, is that where you landed yours? Perfecto. And then let me get a different color, and we should have a graph that looks like that as it goes out. Cool. Okay, let's do a few that are past 39. So, Elke, any ones that you want to?
Yes.
So, oh, it's a nicer thickness there.
I do not have my paper. I think
No
it was-
problem. Then I'm just gonna just select few. Yeah, select few here. How about, let's go 43 real quick here. It says write an equation for the function that is described as the given characteristics. The parent function is x squared. And move 2 units to the right and 8 units upward. All yours, guys. 2 units to the right and 8 units downward.
Sorry, what units?
It's 2 units to the right. Here it goes. How about this? Right 2, down 8. And I think most of you guys already have it. So G of function says 2 units to the right would mean -2. And then down would mean -8 on the outside. Are we good there? How about 47? So the parent function is the absolute value of x. It is moved up 10 units and a reflection about the x-axis. All yours there. See if there's any others. I think that's That's it. There, we got two, three, you got three honor questions, but that's about it. You want to take a look at some honor questions too, or no?
Yeah, can you just do the last one for the honors?
Absolutely. Sure. Okay, for this one, let's see. X-axis reflection. What do we do there? Is it multiplying the outside or the inside for the x-axis reflection? Outside. Okay, sounds good. So outside, we got a multiplier of negative. No horizontal shifts whatsoever, so it's just absolute value of x. And we go up 10 units and we are A-okay. Real quick here, you guys ready? Just to clarify. So do you guys remember when we were saying about the x-axis reflection? It's like this right here. It's the negative of the function itself. We good? So it's a multiplication of the function, right? So what happens here is this right here. It's going to be like this. It's going to be that. All of that gets multiplied by a negative. So to simplify it, then it becomes negative. And then yes, this guy will have to become a minus as well. We're good? You can write two. You can either have the parentheses around the function itself like this, or you can write, you can multiply in the negative. Either one is just fine, even though the book only gives you one answer. Okay, and then one last one. So we'll be going. Let's see, identify the parent function shown in the graph. Write an equation for the function. Use the graphing utility to verify it here. So let me jump to the next one here. This is 1.7. This is number 59 or 71. 71, is it the profit ones?
I
Think so, maybe. 71 then, okay. This one is management originally predicted that the profits from the sales of a new product would be approximated by the graph shown below. So there's a little graph like this, goes from 0, 0, it goes up for a while, and then it changes like that. And I think the end result is 4, and we're at 40,000 over here. It says use the concepts of the transformations of graph to write G in terms of F. So there's that. The profits were only 3/4 as large as expected. So this guy has to be, it's going to go down. Is that right? 3/4. So we have a down projection. Now I'm going to go like this only. So it only grew 3/4 as much. The profits consistently $10,000 greater than predicted. And then it was $10,000 higher each time. So 10K. Okay. So let's see, the function itself, I think is just f of x. This is just f of x. So we're going to write g of x in terms of f of x eventually. So what happens from here to here? What happens if we have to squash it down? I think we're going to, for vertical stuff, we multiply just the same multiplier. So now it's going to be 3/4 of x. Okay, and then it's consistently $10,000 higher. Absolutely, 3/4 plus 10,000. I'll put 10K. Yeah. What did you do, right? Oh, there's a part C here. It says that there was a 2-year delay in the introduction of the project after sales grew, profits grew as well. So there's a 2-year delay. So this graph starts off, really in a sense, here, goes up like that. So a 2-year delay. So really, in a sense, this graph is moving over to the right by 2 years. So I think I have what I need. This is 3/4 f of now x minus 2, because I'm moving over to the right, plus $10,000. Does that make sense there? I'm just looking at the back of the book here, see how they have it here. Oh, you know what? We were awesome. We did the whole entire function. What they want us to do is just break it down by different pieces. So ALGA, sorry. So for A, that's the answer for A, is just 3/4. Yeah, so I thought they wanted us to kind of complete the function entirely. This one is just f of x plus 10,000. And part C is f of x minus 2. There's your. So we did it all together because we're awesome like that. All right, does that help?
Yes.
Okay, any others? Going once, going twice. Okay, let's jam. We got 1.8. So we did transformations, and transformations are pretty much more like a the geometry of doing it, right? We were talking about functions, how they transform. So now let's jump. We're going to look at 1.8, something called combination of functions, and we're going to look at it in a algebra kind of method here. Combinations of functions. And then we're also going to take a look at something called, it should be all one single line, but composite, something we don't do with numbers. It's called a composite function or functions. So combination of functions and composite functions. That's what we're going to take a look at here. Go back. Okay, so what does it mean to combine functions together? Just like numbers, we combine functions together by adding, subtracting, multiplying, and dividing. So let's kind of do that real quickly here. Let's write out each of these here. So for number one, sum. How do we add functions together? There's some notations to it. You can just write f plus g, just like that. And that means you're adding two functions together. You can also write f plus g with the little x all the way on the side. That does not mean multiply. That means the f plus g is added together with the x being the variable. Or you can write it like this, f plus g plus. All three of those mean the exact same thing whenever you see it in mathematics. So let's go the other one here. Subtract, or something called difference. So f minus g, parentheses f minus g of the variable x, or f of x minus g of x. All mean the exact same thing. Let me spell that a little better without the chicken scratch here. Product. Product means multiply. How does that happen? This one is f and g are just close together by themselves. Right next to each other, we got ourselves the multiplication of f and g. If you want to introduce what the variable is, because sometimes we need to do that, we have that right there. And if you want to show how you're actually doing the process, it's f of x times g of x with a little dot in the middle. And last one, the quotient. Okay. Quotient Q-U-O-T-I-E-N-T. All right, and then we go like this. Just f divided by g is how we write it. We can write it as f divided by g with the variable declared, which is x, or we can write it as just the division between the two. The only thing that we've got to keep in mind is this right here, is that the g of x cannot be a 0, or else that's not cool, because then we have to divide by 0. You know, I'm gonna go out of this because I like the I like the thickness of the red color over here. That's cool, that's cool. And number three. Number three. Cool. All right, keep it like that. Okay, everybody good there? Let's jam. Exercise 1. Let's go with it here. Oh, sure. No problem.
No, Abby, you have to suffer. That's what it is.
Exercise 1. So here it is. I'm going to go f of x is equal to 2x plus 1. G of x is x squared plus 2x minus 1. And then let's find a few things here. Find f plus g. Find f minus g of x. And find so on the first one, I'm not even declaring my variable. That's just one way to write it. And it means the exact same thing as f plus g of x. Right? X is assumed to be there. So all yours go. Do we simplify? Yeah, absolutely. All right, so f of g, so we can kind of do a few things here. If we want to put in all the variables, all the different pieces, we can. But functionally, what we're trying to do is we're trying to add f of x plus g of x together, right? And so if we say, okay, f of x is 2x plus 1. G of x is x squared plus 2x minus 1. And then we just add them together. So this is x squared. Is that 4x? Is that right? And then those cancel. So done. That is so cool. So what we've done is that we actually created a function, a new function. So what we normally do is we write the last notation from the previous slide out right here, because it kind of tells us exactly where the f is going to be and the g is going to be. It's all yours for that. So let's see, and I like to put parentheses in because then it tells me exactly what I used and where I put it into. And then this one does need a little bit more work than the previous one. I'm going to get rid of my parentheses here. So I'm going to distribute the negative into here, here, and here. And anybody with the final answer? Plus 2, are we good? The x's are got canceled this time. Cool, okay. And the fun one. 2x plus 1, x squared plus 2x minus 1. All right. Have fun with that one. It's foiling out, is that right? We have to multiply this to here, that to there, that one to here, and then here, here, and here by the time it's ended. Give you guys a 20-second head start if you haven't done so already. All right, head start over. How about 2x cubed? Everybody good there? First one here, let me erase it as we go. So this one is 2x cubed. This one have to be a 4x squared. Let's see, this one's going to be a minus 2x. We'll get ourselves a plus x squared plus 2x minus 1, and eventually, let's see, 2x cubed. Five x squared. Two x's are gone again. Is that right? And I got myself a minus 1. Tell me if you guys get the same. Yep, okay. Cool. So we add, subtract, multiply, divide functions here. Before we get to D here, I want to take just a quick little parenthesis here. So when we add, subtract, and multiply, divide functions, what we really are doing is we're creating a new function that has never, or knowledge we haven't seen before. We're good? So maybe just a quick aside here. So let's say, just pick out, let's say we look at it, we work at a dealership. Again, don't need to write this one down. This is kind of just for us is to kind of know. We work at a car dealership and we have certain managers. One manager is pretty cool because he's the general manager and he looks at the total number of sales that are done. We're good? And he has a formula for that. Total sales, we'll call it F of X. And then we have another manager that we only sell trucks and we sell sedans. We're good? That's kind of the two major cars. We're good? Simplified problem here. So a person keeps total on sales, total sales always. Another one, the other manager keeps a really good tabulation of truck sales. G of X. The guy that does the sedans, he struggles in math. He doesn't do so hot. So now the question is, I know total sales, I know truck sales. Absolutely, but notice real quick here, we have truck sale information, we have total sale information, but by subtracting, by doing this right here, right? We have new information that we did not know before. Are we good? And so it is a whole new function. It's new info. And now we just figured out the guy that did not do his math. We figured out the exact precise answer for sedan sales. Are we good? Oh, but maybe he sells a lot. So we want to keep him because he's a good hustler. Just can't keep track of the numbers. Okay, but does that kind of make sense here? It's a whole new information, it's a whole new set of ideas just by subtraction or just by adding or just by doing things like that we did not see before. Let's see. Maybe another one here would be US population. When we think about US population, we do a census, right? We do a census every year, so that gives us total population, true? And then when there's births and deaths, usually that happens in the hospital. So we do have, I'll put BD, we're good? Births and death rates are pretty easy to calculate real quick here, right? We just calculate, the hospital keep tracks of those, the funeral homes keep track of those, right? Those are good numbers here. And so births and death rates are good. And so if you take the census data and you subtract the birth and death rates, what do you have that you did not know before? No.
How many people are alive?
Uh-uh.
I guess not the expected population.
So let's say for like the last 10 years, right? We say we took a census data, right? At 2020, right? We also took census data at 2010, right? And we did this right here. We took the census data, how many people are in the US, and we subtracted off the births and the deaths rates at.
How many people have been alive that time?
Cool. That would be census still. Interesting. Okay, I'm gonna go for it here. The new stuff is immigration, right? Because the only people you add to a new society, right, is either from immigration or right, or from births and deaths, right? So you have a whole new set of data from that based upon just subtraction of the two. We're good. And so again, new information out of nowhere. Okay, let's jam. Let's go back to over here. So notice we did this one right here. Let's pick on B for a little bit. We had a function, we had another function, we subtracted the two functions from each other, and we got a new function called negative x squared plus 4. So for D, can you tell me what is, and we'll do it two different ways. Don't need to graph it. We'll do two different ways here. We'll split them up. And so one way is, don't we already have a function? Did we make a function called f minus g? Yeah, we have a function called f minus g of x. It's a generalized function, which is negative x squared plus 2. Can I plug in the 2 into that? Yeah, because notice it's just a variable here, right? It's just the 2 being the variable. So if I plug it in, the answer is negative 2 is good by me. Too many 2's over here. Okay, or I can do this. I can say, you know what? I can go all the way back to my previous functions. I can say, what is f of 2? And I can say, what is f of g of 2? And I can subtract it from each other. So then let me plug this in. F of x originally, wasn't it originally, it was x, 2x plus 1? Check just to make sure. Cool. Okay, if I plug in f of 2 into it, I give myself 2 times 2, which is 4 plus 1 makes 5. Then the original g of x, the original one was x squared plus 2x minus 1. If I plug in 2 into here, I get myself, let's see, that's going to be 4 plus 4 minus 1, that's 8, 7, is that 7? I'm showing this taking a little bit longer than I want, isn't it? That's a lot of them. So hold on though. So then I have this number. Here's my f of 2 minus g of 2 now. F of 2 is 5. G of 2, 7. And the answer is negative 2. Same exact answer that I got with a lot more work. So what's better? Better is when we make a new function, we define it to be this, and then we can crunch numbers a lot simpler than going back to the original problems that we had. Okay, we have one issue that comes up though, is that when we do quotients, quotients are the problem. And I think we could still keep with the same one here. Let me just check here. Let me just check if it's factorable. No, it isn't. Okay. So how about f of x is equal to, let's use the same one here. G of x is equal to x squared plus 7x plus 12. Find f over g and give the domain. Okay, watching the time here. So we've got a little problem here. So remember, whenever we put something on the bottom in our denominator, we have some issues that come up with it, right? And so when we find f divided by g, automatically we have ourselves in trouble because now we have to exclude terms that this cannot possibly be a function anymore, or the domain does not work. And so let's go for it here. So f over g of x, by definition, is just f of x over g of x. And by what the values we have on top, it's just 2x plus 1. On the bottom, it's x squared plus 7x plus 12, but now we have to figure out the domain. Because originally it was just fine. Those are both polynomial functions here. So we got to do an extra little step. We've got to say to ourselves, since x cannot, or since the denominator cannot be equal to 0, when does this give us a 0? Two numbers multiplied to 12 add to 7. So then x is equal to -3, -4. So then we go up here and we say to ourselves, that's a great function. That works just fine whenever x does not equal -3 or -4. All right, I'm good there. Can we write this in terms of, interval notation, guys? Can we do it in terms, can you write it over here in terms of interval notation? Intervals where you have those brackets and you have parentheses and you kind of move from left to right on the number line, all the good stuff there. Very true. Good, good. It's trying to trick you. Okay, so let's see. All the numbers that work go from -infinity all the way up to
Or sorry, infinitely close to. Oh, wait, infinitely close to -4. sorry.
Yes, right. If you go from -infinity, you're going to get to -4 first, right? Before you get to -3. So -4, -4 to -3, union -3 to infinity. Are we good? There's your, that's my little phone going off here.
How do we mark it as infinitely close to -4?
By a parenthesis. All right, let's see. You don't have time to do that one here. So are we good there with this? Let's jump to something called one more thing. So with numbers, we can add, subtract, multiply, divide numbers. We could add, subtract, multiply functions. That's cool. And then we have to do one other thing that we can do with functions that we can't do with numbers, called composition of two functions. Composition, it looks kind of funky, but here's what it looks like. It's like this. It says F, instead of having a closed dot for multiplication, it's an open dot. Yeah, we're running out of symbols in mathematics, so we just start rehashing symbols and redoing stuff. So it's an open dot, not a closed dot. Now I can write it like this. Sorry, I can write it like this, sometimes called fog. Fog of X. And what it means is the G function is actually sitting inside the F function. We stuff one function into another function.
So X was two, then, and G of X
I
was.
was just doing it, but
Yeah,
I
actually,
forgot
I'm
now, I
saying.
forgot to process
And then
it.
every X.
I know, right?
Let's try. Exercise 3, I think, is that where we're at? Yeah. And we have. Okay, we have f of x is equal to x plus 2. And we have g of x is equal to, 4 minus x squared. How about that? That'll be good. What I want to know for A is I want to know f goes with g. You got it. Go fishing for a pencil. Oh, awesome. Good job. Okay, so we're gonna stuff the g function into the f function. So here are a few ways to do it. And it kind of just clicks eventually here. So let me write the way it's supposed to work. It's this one with the variable x, or we write it like this, right? Okay. Let's try it. Boom, boom, boom. Let's put it in. What we're going to do is we're going to leave the f as named on the outside. And on the inside, we're actually going to stuff whatever g is. G is 4 minus x squared. So it's almost like this. This is probably a good visual here. We're going to take this function. We're going to stuff it into the x over here. Good there? So let's start writing the f function. Whenever we see x, we're going to substitute 4 minus x squared for x. So as we do that, we go to this, boom, and then plus 2. Because what does the f function do? F function just adds 2. Is that right? The g function, it squares something and then subtracts it from 4. So now what we've done is we've created a function that does both at once. So that's what a composition function does. It actually adds functions together. So you're dealing with one function as opposed to 2 different functions separately. So notice what's doing. It's squaring something, subtracting from 4, and adding 2 at the same time. How does this kind of work in real life? It's more like, let's say you were going to buy a computer and you had a 10% off of the computer, right? An extra $300 off the computer. And so what this one do is we'll combine it together so that you have to do separate calculations. You just do one calculation for the price.
The issue is they always do separate calculations, that they give you the worst deal, so that in this case, they would give you 10% off of the 600, or sorry, off of the 300, not the 10% off the 600 once you do 300 off.
Sometimes, yeah, it depends on how it is, the advertisement is listed, yeah, because if it says an instant $300 off, that means they take it off the top and then 10% off that later, or instant 10% off. Okay, real quick here, let's go the other way. So yes, we can go the other way.
An instant 300, or
Let's go.
That's when you talk to the manager. So can we go backwards? Absolutely, guys, we can go backwards. We can go g of f of x. And we can go
Replace
G of X of X. Where is it? Yeah, it's G of X of X. Is that what the O stands for, is up? Why not?
Yep. The open, that little open thing there. Okay, so what is the formula for f of x? I think it's x plus 2, right? What f does is it adds 2 to it. And then let's rewrite the g function. As we keep on rewriting it, as soon as we get to x, we're going to plug in x plus 2. So guys, talk to me. What are we writing?
X minus x plus 2 is
No, let's see. Start writing the G function. What should we write down first? There's a number there called 4. 4
That's what I meant to say. In my head, I was like.
minus, and now we put in x plus 2 to the second power. Okay, with that, and we're going to expand this out. So off to the side, you can either do x plus 2 times another x plus 2. Anybody know the shortcut though to do that?
X squared plus 4x.
Plus 4x plus 4. Yep. Now careful over here. So notice we're subtracting that out though, right? So that parenthesis still has to stay because we're subtracting the expansion of this out. So now distribute the negative inside here everywhere. And final answer is negative, yeah, minus x squared, or negative x squared minus 4x is the expanded version of it here.
Calculator that I have, there's 2 different symbols for negative and minus.
Oh, awesome. On a calculator. We'll finish off with that. Da-da-da. So this is a subtraction symbol right here, Noah. And this guy's a negative symbol. They look like the same, they're totally different. If you plug in one for the other, it's gonna mess it up. Got it. Okay, class. See you guys on Friday. So 1.8, I think you guys should have enough information to do 1.8 homework.
I know, right?